A few people have asked questions on Khan Academy about what happens to the vertex and some other graphing related questions. I did some videos on graphing to help augment what Khan Academy and Sal's doing. But this time I want to come in and show this is a type of question that was actually kind of common in tests and in my algebra class when we dealt with the conics. You may notice that I've got some basic information that was given to me. I have the vertex. It's already been graphed for me. I have one point. It's already been graphed for me. I know that this is a parabola. I know from these two pieces of information that it's going to be something pointing down. Okay, so just by the virtue of that, I can immediately graph this point right here, because I know that if I go through -1, 0, and that's 2 over from the line, see this right here would be the line of symmetry. Okay, it has to be because the vertex passes through it. So the line of symmetry is at x equals -3. So if I can go 2 over at 0 and hit there, then I can go 2 over the other direction and hit here. And I'm going to label that as -5. Yeah, -5, comma, 0. That is one of these add points. I've got that right off. Okay? Now, I need to find the focus and the equation of the directrix. This is where I'm going to add in a concept. And that concept is this equation that I briefly introduced a while back. Y equals 4p x minus h squared plus k. Okay? Now, the vertex is hk. Okay? That's when you shift a parabola, you are shifting the vertex. So I have those 2 points. And then P is a very special point that I'll get to why it's special after I solve for it. So, I know that my HK is -3. So if I say Y equals 4P, well, it's going to be x minus a -3. Okay, well, that is the same as saying plus 3. Okay, so I've got x plus 3 squared plus 1. Okay, nice. Now I have an equation. Well, the point 1, -1, 0 is in that equation. So I've got a -1 here, and I've got a 0 here. And those have been given to me. So I'm going to say 4p times -1 plus 3 squared plus 1. Well, now that's an algebraic equation with one variable. So -1 minus 1. So I've got -1 equals 4p. Well, let me combine those. It'd be 2 squared. That becomes 4 and 4 times 4 is 16. So negative 1 equals 16p. That's just some basic algebraic manipulation. If you have trouble with basic algebraic manipulation by this point, you're looking at the wrong video. You really do need to go back a few. Because you should be at a point now where you can follow the basics, because if you can't, you'll have missed enough key stuff to where you're not going to be able to continue into topics like this. So you should be able to solve this equation without any real help from me and get the same p equals negative 1/16 that I just gave you, that I just did. Okay. Now, why is p important? Well, in a parabola, p is 2 places in there. No, I'm just going to do this bigger. This distance here and this distance here are p. So from the vertex to the focus is p. From the vertex to a point on the directrix is actually negative p. The distance is p, but it's negative p. So if I go back and I look at my negative 3 comma 1, and I go negative 3 comma 1 plus a negative 1/16, I end up with negative 3 plus, that's 16 sixteenths minus 1/16 is 15 sixteenths. That is my focus. Bingo! We have one of the answers that we wanted up above. Before I go back up, if I take negative 3, 1 plus, or 1 minus, minus the negative 1/16, which is actually plus. Then I'm going to get the negative 3 comma 17 sixteenths, and that is a point on the directrix. Okay, which, because I have a negative, mine's actually going to be with the focus down there and the directrix up above. So 15 sixteenths and 17 sixteenths. So really, really close. So like really, that's even too far in there. But my focus, I can write in on the answer because they've given me that point, that spot. Negative 3 comma 15 sixteenths. And then directrix is actually x equals 17 sixteenths. That's what they mean by the equation. What x For any y, x equals 17/16. That's the equation of the directrix. So actually, it's an easy answer. So now all I'm left with is points to finish this graph, and I already put in 1 point, and some professors might say, okay, yeah, that's enough. 1 point, you go on, blah. However, some professors are going to say, no, you have to have more points. Well, I have an equation now. I know what P is, I know what all this other stuff is. I can plug it into the equation. So 4P is 4 times negative 1/16. 4 goes up there. Then that reduces, and I get negative 1/4. Okay, so that's my 4p value. So if I say y equals negative 1/4, 0 for my 0 point, that's this line, x equals 0, plus 3 squared plus 1, I get 9. So 1 minus 9/4. Well, 1 is 4/4. That becomes negative 5/4. So 0, negative 5/4 should be about right there. 0 comma negative 5/4. Always label. Always label. Unless your professor specifically tells you not to. Okay. And then by virtue of that, I should have 6 with the negative 5/4. That should be on there. But if you are with a teacher that says, show all your work, you're going to have to come down past all your mess that you've made and do, 6 minus 3 squared. And this was y equals negative 1/4 plus 1. 6 minus 3, this is negative 3. That squares out to my same, negative 9/4 plus 1, which the answer is the same as what I had up above. So, yes, that point is on my parabola, and that is a reasonably accurate sketch. It's the important thing. Sketch. So that satisfies the last part, except for the fact that I almost forgot to negative 5/4. Must always, they'll ding you on this. So negative 6, and there you go. That would be a solution to a test question in a college algebra class. Whoops, hold on just 1 second here. I just noticed something. That is not an x. The directrix in this case is on the y-axis, paralleling the y-axis, and where I got it from was the y part of that equation, which is why it's it's a y equals, not an x equals. It's for all the line that any y is 17/16. Would have gotten 1 off on my test without fixing that.